Hola and hello. In this lesson, we will expand your object-oriented programming knowledge by learning about classes. A class is the blueprint of an object. So let's see an example. If you recall from previous lessons, we used car as our object example. So we will create a class called car with an attribute color, which will be red, and we will create an action within it as well. And we will call it check color, which will simply print out what the color is. We see that the action check color is simply a function that prints the color attribute. When a class possesses a function, it is actually called a method since it belongs to an object. And since it is a method, you have to pass in self as a parameter, as seen over here and highlighted in mahogany. For best practices, one should always use the init method inside a class, which looks like this. Init. All right. The init method acts as a constructor and should be written first, especially since we cannot create class attributes outside of a constructor, as seen in our code, highlighted in red. So to fix this error, we simply have to bring it into our constructor. And just like that, it recognizes self and everything seems to be in order. Let us create the actual object now by calling the blueprint of our class. So we will create the object and name it myCar, which will use our car class as the blueprint. Here, myCar is the instance of our car class, which means that it is an object that has the structure of the car class. The class example that we see above is this object's definition. Additionally, it is important to note the two leading and trailing underscores of our init method. This indicates that it is a built-in Python method, so that the Python interpreter will treat this method in a special way. In this case, since it is a constructor, it means that this method will be run when creating an instance of the class. So it will automatically be run right here. We can simply call an action of our class object by using our instance and using a dot to say that this following statement belongs to our object. And in our case, we have check color, so we will use that. And when we run our program, we can see simply it prints it out, no problem. For best practices, developers create object definitions or classes in separate files. So let's do the same here. Let's create a new program by right-clicking on the folder, going to new Python file, and we can call it something like car class. Okay, and now simply copy over our contents to our car class, click save. We can now go back here, comment our old class out, and we have to now import our class from our new program. So we can do something like import car underscore class, and PyCharm knows this exists, so we can click enter, autofill it, and now when we actually call our class object and create myCar, we need to add something like this. And now everything is in order, so when we rerun it, we should get the exact same output. And we do. For simplicity, we can also import our class directly from our program. So we can do something like from car class import, and then we can call our class name, which is car, and we can say import car. So now we don't need this prefix right there. And when we run it, it's the exact same thing, just much cleaner. This statement right here is basically saying we only want to import our class called car from our program called car class. So if we had other additional information in our program, then we would completely ignore it upon the importing. We can change the color of our car object by simply writing mycar.color, and here we are referring to the attribute of our mycar instance, and we can assign it to something like blue. All right, so now when we run our program, we can see it is blue. If we were to create another instance of our class, for instance, we can say my Volvo, and we'll create a new instance. And when we call my Volvo.checkColor, we can see, let's comment this out. We can see it will be red, right? Because it's a default value. So if we have both of our programs running, we can notice there's no overlap and they are their own unique instances. This is because when we work with my car object or my Volvo object, we are working with the instance of the car class, not with the actual class itself. Looking back at our class, we see the self keyword quite a bit. So let us explain it a little bit more. Self simply means that the particular attribute is associated with the instance of the class. This is how we were able to previously modify the object's color attribute independently. To reiterate, by passing the self argument into any of the functions inside of the class, such as right here, we indicate that they are methods, hence they belong to the instance of the class, such as my car or my Volvo. Fantastic! You have now seen the structure of a class, how to implement it, and how to import it specifically from a different program. There will be no quiz for this lesson, as you will continue learning in the next lesson, where we will demonstrate examples of the 4 object-oriented programming principles learned in our previous lesson.